Welcome back, everyone. And next will be our last talk for today. We will be listening to the topic of quantum computing concerns. So please join me in welcoming Soenil Soebedar, founder of SOEBIT Cybersecurity. Please give us a round of applause.
Hello, Kapun Kap. I'm Soenil Soebedar from the Netherlands. Thank you for joining this last session about quantum computing concerns. Short an agenda, some basics about quantum computing, some investments in the globe that has been done or still ongoing related to quantum computing. Some fundamentals, just basics. We are not going to make it very technical session, otherwise I should be able to other stage to speak. So it will be very basics about some fundamentals, components that we are using in quantum computing, some cybersecurity related threats where we should be able to consider, a future plan, how we can proceed with cybersecurity and quantum computers. Some takeaway tips, general tips could be motivation tips, and I guess if there is still time, I'm able to ask some answers also on those questions what you are raising. Before moving, a short disclaimer. I am also a part of a government organization as a contractor working then in the Netherlands. So this presentation is based on my own opinion, not related to any other government or other kind of companies related to that. So there's a short disclaimer about it. So last November, I was also a part of the CyberSec Netherlands to speak also about this topic. Here are some pictures you are able to see. But the main part was I got also some questions. And I add the questions and the answer in this session also to share with you all. So basics about quantum computing. So starting from our traditional computers where we are working for a long time with the bits and the bytes, moving forward to the supercomputers what we are using in the cloud environment, and a lot of other ways where we are able to use the supercomputers, but also in backgrounds and other kind of applications we are already using. Then the future or the quantum computing one, where we are not only using the 0 and the 1s as in computers, but also the value between those two, 0 and 1, can be used. More info about it. So when we compare and see a sample about quantum computing, recently in December 2024, Google Quantum Project AI combination with quantum computing project Willow, you are able to find it on internet. They make a calculation. If you are able to do an mathematics or any kind of calculation where you are able to do it with the quantum computers in 5 minutes, supercomputers will take 10 till 25 years, where the traditional computers will take 10 with 25,000 years. Of 1,000, so many 25 zeros can be added in so many years. So you can imagine what is the difference between the traditional computers and how fast the quantum computers could be. Basics about quantum computing, the principles, what they are using, and those principles are not new for us because we are already using this principle. Only we will add those techniques and mechanisms based on molecule, atoms, photons, and electrons, not only on the computer's part, but we are also using it in MRI scans. Lasers are already using, GPS are using this kind of techniques, solar systems, etc. So you are able to see technique is already in use. Now we want to move and make the movement to the computer systems where our computers should be able to become faster. Moving on. If you compare the classical computers with some quantum computers part, you will see the difference related to processing powers, encryption, and we mentioned encryption already. The cryptography part will be also a part of it, and the defense mechanism, how we are able to defend it. So those are some of the items. You will see the comparison between those two, where traditional computers, we are able to do a lot, but we are also knowing that with quantum computing, we are also able to break those encryption method and what is currently in use. So that makes the difference. We know quantum computers can be much faster in processing powers. So those are some of those items related where we are able to consider. Some facts, if we are checking on what's going on and which kind of facts we are, as I mentioned, they will be very fast. So those quantum computers can be 10,000 times faster than the supercomputers, as in the previous slide mentioned. So in the previous slide also a sample how it will be different, how fast you are able to do where we are normally using the other computers to do it. The part that quantum computing will replace our current computers, that will be not the case. And in one of the slides I will explain why we are able and when we are able to use more about the quantum computing. They are operating in very cold environment now, minus 273 degrees Celsius. In those environments, those environment has been set up. We need to have about at least 1,000 qubits to do and make a proper use of it. So in one of the samples I will show you one of the algorithms what we are using, we call it RSA, on that how we are able to break it if we have those kind of parts. And we need to have millions of quantum bits, as we have now only thousands, it should be millions, and when we're having those millions, we are able to mention we are quantum supremacists. So quantum supremacy means that we are at the point where we are able to say we are able to do with the quantum computing the same as we are able to do with our supercomputer or traditional computers. So we don't reach that point yet. But in the upcoming slides and more information I will share about it, how and when we should be able to meet those, and why it's important to consider now already. So here the sample. So we need 2,000 till 3,000 qubits to break an RSA key. That is one of the encryption methods, and RSA is very common use across the globe. Long time we used RSA, still we are using RSA encryption. So we need to have between 2,000 and 3,000 qubits to break it. And if we make it harder, instead of 2,000 to 3,000 bits environment, we need to have more than 5,000. So as you can imagine, we are now getting allowed 1,000, maybe a bit more. It's not far, we are able to reaching this kind of amount. So then, why and what is going on in the world of quantum computing? Some basics information or an overview. This is a report of October last year where you are able to see how many countries, how many governments are already spending more than 42 billion US dollar into quantum computing related projects. You can see there are some top companies, some put a lot of millions, billions on it. So you are able to see. But also Thailand, you will see, they put at least 200 million baht on it, so about 6 million US dollar. They are also investing. So not only the large, big continentals, but a lot of them are dealing on it and related to this. So there should be something where and why they have considered to put so many amount of money into this kind of projects. Here are some of the top 4 on research and the leaders who are dealing. China, South Korea put a lot of it, India, Japan, and you can collect the European, and that can be Germany, France, etc., European Union. Together you can collect also of them. So here are some reports, details, you can find more details on those slides related to it. And if you compare how and on which part they are connecting, you will see they are related to grants, patent publications, and investment they are doing. So at one side you will see the global, the world level, and at the left side you will see the part for you, right side, the part from European Union point of view. So, some fundamentals, some basics actually, how and what about quantum computing. So as I mentioned, we are able to solve, and which kind of problems are we able to solve with quantum computing? So searching should be easier, faster. If we have more power, we are able to do it. Or we can optimize it, we can make more use and use the situation on quantum simulation on it. Adding machine learning in combination with quantum machine learning, so not the basic machine learning, but also the way how quantum should be able to use the machine learning part, that can be added. And we can solve the break-in part on the cryptography part. And as I mentioned, are the quantum computers always faster than the classical computers? Answer will be no. But we are still able to use a lot of them with the classical computers. But as I mentioned, mainly machine learning part in combination with quantum computing with one of them, what will be included. So here are some of those highlights where we are able to work. We are dealing with a part of quantum hardware, so the physical, the qubits, the quantum gates, and all those items that are related, the environment we need to have, the infrastructure we need to have, the software based, where we are able to build those applications to create it. Also the part of the quantum algorithm can be a part of that, and then based on the applications what we are using. On the application moving forward, that could be the cryptography part, where we are dealing and should be able to get those information about the cryptography. Moving forward on the cryptography and cybersecurity threats, you will see here two of them, where two of those main concerns. We are able to crack it, we are able to use the password cracking methodic, and we are able to crack the cryptography. Here a sample with an AI in combination with password hacking tool, where you are able to see how many years it can be take to crack the password if you are using this kind of password. So you are able to imagine all the years what has been mentioned, and in my previous slide where I mentioned where we are able to use the computers with 25 zeros so many years, so that means that some of what has been mentioned here can be removed. With quantum computing, we should be able to do it very easily. Those environments where we are not able to crack it, the currently situation is that organizations, hackers, bad actors are already trying to use that method to harvest it now and decrypt it later. So they try to collect all the information, all the data, also those usernames and maybe only the usernames or the environment. Later on they should be able to try to crack it. But now with the traditional computers you can't crack it, but put it, store it somewhere. While those quantum computing will be available, you are able to crack it and make use of it. So to understand a bit basics about cryptography, so cryptography part is where we are able to, when we are communicating from A to B, we are able to encode the information, decrypt the information, and later on we are able to encrypt it. Simple sample, anyone who is using WhatsApp as example, you have seen the message, your message has been encrypted from end to end. So those kind of techniques in the background has been used. Where are we currently using cryptography? Across the globe. If you are doing a website, on an e-commerce, our ATMs are using this. In your chip manufacturers are already using cryptography. Your computers, your servers, log on, all those, but also our devices on our government environment, and also when we are dealing with crypto devices to encrypt sensitive data, especially in the military or government environment, where you are able to make use of those kind of encryption method. Of course, they are adding their more level and more higher encryption on it, but even that could be one of the part what should be able to, you should be able to encrypt. Impact can be, if you are checking where are we using, then the question, and this is actually an answer on the question what I got in the Cybersec Netherlands, is which kind of branches and which kind of environment will be affected. So actually, all simple answer is anyone. If you are a government organization, or you are a salesman in a web shop, or you are working for the railway industry, the healthcare, any environment can be affected to this kind of situation. So as an example, in one of the slides, you can see here are some of those examples. So if we don't get the power and gas supply, we are having issues. If we have the issues with our traffic lights, problems, and those are all the critical. Our passport system is not working. Example, I'm going to the airport and I'm not able to check in because the systems is not working. They can't validate who I am. My passport will not check, so I will get issues. But what if those chip, what is in my passport, has been hacked, or those environments are not secure enough? You can imagine what kind of impact this kind of situation have if you need to replace all the passport from all the persons or all your country where you are living. Those chips need to be replaced. So logistics-wise, it will be a huge operation. So those kind of situation we want to avoid. Here are some of those cryptography algorithms, techniques we are able to use. There are plenty of them, but here are some. Some will be impacted, some maybe not, but that is just an idea to have, to knowing what kind of cryptography is going on. What will be this impact? Our risk situation will be, we can mention, as I mentioned, the national security can be a part of it. Critical infrastructure can be a part of it related to that. So it can impact, having impact of our risk. The affected environment will be key. The public key infrastructure one can be the one. So TLS and SSL, so more for the technical persons, they should be able to consider also, but also our securing VPN connection, what we are currently using, can be impacted. So post-quantum computing, the key distribution one, so those kind of techniques can be, and we need to consider how we are able to work on it. So as a simple question and answer, actually part on to explain a bit more about the post-quantum, PQC we call it also. So a situation I'm having at home, I have a safe, and on my safe I put a lock, and I got the message from my neighbors that there are persons able to crack that lock. So I get this information in the news. I should be able to consider there is something, so there should be, my lock is not secure enough. So I should consider to renew, or okay, leave it. If the person come and they are able to break it, they will take all the stuff from my safe. But mostly we don't want to have it, so we need to consider and be sure we have a nice, better, secure kind of lock where we are able to secure it. So that is actually the simple message for PQC. We know what's going on. We need to consider, even don't matter which branch you are, we need to consider, or sooner or later, this will happen. So when, this is one of the upcoming slides, not sure, but we know it will be changing our life. Here are some tips and parts what you are able to do. So make an inventory of what kind of cryptography you are using. Make a plan how and which kind of action you need to take to consider if you want to proceed. What are your PQC risk, which can be affected? In the previous slides, some of them has mentioned. So check also by your vendors where you are getting this support or this application or any of the part what they are dealing. Are they PQC ready? So there are some of them where you need to consider before forward or moving forward to consider. So here is a simple report from the Netherlands government. You are able, it's in English also, everyone is able to use it, where they mention It could be that we are able to crack the password between 2020 and 2040. From and if I read some other documents from, this is an estimation from some experts, but other kind of experts said, if we know how fast we have seen the change in AI for ChatGPT, where we was aware that it could be so fast, if this kind of situation happen also in this situation, so you can easily make the 2030 to maybe 27 or 2028. So by knowing this will happen, we need to consider, or we need to prepare it already. They created a report, and a simple report with 4 steps where you are able to manage, and the steps you need to consider. So based on those steps, you are able to prepare yourself and be quantum ready. So as I mentioned, it's a report from the Netherlands. The source has been mentioned. But of course, I can imagine that also in Thailand you have also quantum computing groups going on. They have also similar kind of reports where you are able to get the information. And it's free. So that advice will be to all those persons who are in any of those branches. Please consider this kind of situation. Here they have mentioned the steps, what need to be done, and how you should be able to consider and proceed on it. So due to time, okay. This is one of the report I got from the TREC, person from Thailand, may be known. This is one of the quantum research programs in Thailand going on, where they are focusing on researches, collaboration with talent, on get talent onboarded, but also collaboration with universities and colleges in Thailand, and a lot of some universities has been also mentioned. So those kind of projects are already going on. So if you need to get or want to get more info, also from commercial point of view, companies who want to do tests on it and want to be sure that you are able and ready in the quantum proof situation, you are able to join this kind of initiative where you are able to test your application, infra, etc., or cloud environment where you are able to make use of it. So the last part, it will be some technical. I will go very quickly to just highlight some of the keywords. So who are technical, please make notes or make screenshot. Based on those keywords, you are able to get a bit more information about it. This is a report from the US, the NIST report, we call it, the National Institute of Standard Technology, known for persons in IT and cybersecurity maybe, sorry. Where they mention public key encryption, we are able to encrypt it based on the ML-CAM methodology, what they are using. The digital signature, what we are using, we are able to crack it and secure it by using one of those 3, Crystal, Sphinx, and Falcon. Those methodologies will be need to be implemented or need to consider to be implemented, at least one of them, where you are able to come and be secure. Here are more details and more technical about the symmetric cryptography, person-known symmetric, and we have the asymmetric one. Symmetric use one key to encrypt it and the same key to decrypt it, where the asymmetric use 2 keys, 1 for encryption, 2 for decryption. But also code-based cryptography and more has been mentioned, where we are able to make use of it and to be sure that you are able to use those kind of techniques. No, sorry. Oh. So almost the last part is some key takeaway. Make an inventory of your cryptography. So even we are talking about quantum, be prepared, know what's going on based on your cryptography environment, what you have, how you should be able to secure it, or which kind of protocol you have. If you don't know what you have inside, it's hard to protect those parts. So be sure, make an inventory. Prepare on the PQC part, as I mentioned in the previous slide. Awareness, and get also a risk assessment from vendors where you are dealing with. Do quantum simulation testing part. As I mentioned, a lot of universities across the globe are working having also already quantum computers available for testing, so connect with them to try to get those information. And the last one is don't wait, start now. As I mentioned, if you are the manufacturer of the passport and the password chip will be hacked, you should be able to do and handle very fast. So you are able to get and prepare already on it. At the end, some quotes, and this is one of the quotes of my dad. He passed away long away, but he mentioned everything we do, we should be aimed to become a better version of ourselves. So don't matter if you are in a security, IT, don't matter. Our life could be, or we should be able to become a better version of ourselves. The last one is a quote of Mahatma Gandhi: the future depends on what we do in the present. Maybe this applies also to quantum. Our future depends what we are doing now. If we are doing nothing, could be that our situation in the future will be different. So these are the contact info. So thank you all for your attention, and contact us if you have any questions.
Thank you so much, Soenil Soebedar from SOEBIT Cybersecurity. สำหรับเซสชันนี้นะคะเราได้เรียนรู้พื้นฐานของ Quantum Computing และ Cryptography ค่ะพร้อมการใช้งานนะคะในการเข้ารหัสในชีวิตประจำวันนะคะรวมถึงบทบาทที่ Quantum Computing จะเข้ามานะคะมีผลกระทบต่อระบบต่างๆค่ะรวมถึงความท้าทายนะคะที่องค์กรจะต้องเตรียมรับมือนะคะเช่น Quantum Attacks ค่ะที่อาจจะส่งผลต่อระบบการเข้ารหัสในปัจจุบันค่ะนอกจากนี้นะคะเรายังได้เข้าใจเรื่อง Post Quantum และ Quantum Supremacy ค่ะพร้อมข้อเท็จจริงที่จะช่วยแก้ไขความเข้าใจผิดเกี่ยวกับเทคโนโลยีนี้นะคะอีกทั้งนะคะได้เรียนรู้ผลกระทบจากการเข้ารหัสแบบผิดๆนะคะและแนวทางการเลือกใช้งาน Quantum Computing ให้เหมาะสมค่ะโดยเซสชันนะคะปิดท้ายด้วย4ขั้นตอนง่ายๆค่ะในการเตรียมพร้อมสำหรับ Quantum Computing เพื่อให้ธุรกิจสามารถปรับตัวและรับมือกับอนาคตได้อย่างมั่นใจนะคะ Please help me scan the QR code one last time for today's session. Please share with us your feedback so we can continuously improve our event. Quick announcement for the after party today. The CyberSec After Dark will be held at Sing Sing Theater, the official after show party of CyberSec Asia 2025, hosted by Prunk and Partners and VNU Asia Pacific. You can purchase the ticket on site at Sing Sing Theater, and the party starts at 9 p.m. And as we wrap up today's program, let me give you a quick preview of tomorrow's agenda. We will kick off at 10 a.m. with an exciting session by Microsoft, followed by a morning panel discussion, as well as keynote sessions from SCBX and Bitdefender. In the afternoon, we'll have a panel discussion on the topic of industry leaders, roundtable, navigating cyber threats and building trust, led by industry experts, followed by a session from Palo Alto Networks. And later in the day, we'll dive into another insightful panel discussion on cybersecurity skill gaps, educating the new generation of digital defenders, followed by sessions from Petera and Delinea. The day will conclude with a closing ceremony. We look forward to seeing you all tomorrow and have a safe journey home. ขอบคุณและสวัสดีค่ะ